Okay, guys, so today we are going to be talking about simplifying trig identities, okay, or I should say simplifying trig expressions using trig identities. So if you look in Google Classroom under today, you will see that I have posted the notes for today. It is a 3-page sheet, okay, and I'm going to talk about each one as we're going through. The first page looks like this, and at the top it says, of course, 5.1, using fundamental identities. And this is basically your go-to sheet. The whole first page is just a reference sheet for you. And so let's take a look at this and then I'll explain what we're doing today and how it uses these. If you look, a lot of what we're going to be doing is substituting things. So you see, you know a lot of these. You know, if you look, it says sine of theta is 1 over cosecant. You know that. You know cosine of theta is 1 over secant. And you know that tangent of theta is 1 over cosecant. So these are some identities that you already know and that we're going to use. Okay? Under that, it makes sense that if sine and cosecant are reciprocals, that if sine is 1 over cosecant, then cosecant is just 1 over sine. If cosine is 1 over secant, then secant is 1 over cosine. And then same thing with tangent and cosecant. There's also another little piece on here that you already know, which is that you already know tangent is sine over cosine. Now you may not know you know that too. When we were talking about those points, right? Those points that we made where we made our little axis. We had the 1, 0, 0, 1, or 0 degrees, 90 degrees, 180. We said that tangent was y over x, sine was y, cosine is x. So in this case, tangent is just sine over cosine, okay? Now we know that tangent and cotangents are reciprocals. So if tangent is sine over cosine, then it makes sense that cotangent is just cosine over sine. We just flip. Okay, so these are a few of our identities you know, and we're just going to use these. You don't need to memorize these. You're going to have the in sheet the entire time. Like I said, it's the first page on your notes. Some identities that are a little bit new to you, the ones at the bottom, Pythagorean identities. Okay, so which ones are really important here? If you look, sine squared plus cosine squared equals 1. This one's a big identity. All these other ones just come from that one. So if you look, sine squared plus cosine squared equals 1. If I ever see sine squared plus cosine squared, I could just replace it with 1. The other ones just come by sliding over the cosine and sine and getting different things. The other one, tangent squared plus 1 equals secant squared. So I can do some substituting. Then cotangent squared plus 1 equals cosecant squared. Again, no need to memorize these. You will have this sheet and you're going to see how I'm going to refer to it when I am simplifying my identities today, or my expressions, I should say. Okay, so again, I will show you how to use this. But make sure you keep this on your hand because I'm going to keep referring to it. Okay, now if you look at the second page of your notes, there are 3 examples on it, and this is what the second sheet of your notes looks like. It has 3 examples on there. Okay, now how are we going to do this? Well, the directions say for you to follow along and copy the notes. So you can either print this note sheet out, okay, and write on it, or you can just follow along and put your notes on a separate sheet. There are only 3 examples. So the directions here say to use algebraic techniques to simplify trig expressions. You want to try to get the expression as simplified as it can go, meaning no fractions for now. The biggest thing I'm going to say when you are simplifying trig expressions, like I say, you don't know what I'm doing yet, but you will, is you should always try to first get things in terms of sine and cosine. So I'm going to put that in here. This is a note you definitely want to have on there. Always put first in terms of sine and cosine. Okay, that means all else fails, you put it in terms of sine and cosine, and then you can go from there. And like I said, we're going to see how I'm going to do that. So now, our first example, let's actually look at what a trig expression looks like. Our first example is cotangent over cosecant. Okay, and our directions say to simplify this, which means we don't want a fraction, and we want to try to get it as simplified as we can go. So what am I going to do first? This note should be on your sheet. Always put in terms of sine and cosine. and use your identities. So at this point, I'm going to stop and I'm going to say, what could I possibly do? Well, I'm going to look at my identity sheet and I'm going to see, what can I replace cotangent with? What is cotangent equal to? And remember, always put in terms of sine and cosine at first. So we're going to look at our identity sheet. Okay, have it in front of you if you can. Cotangent, I'm going to go to it. If you look, what is cotangent? Cotangent is cosine over sine, okay? Yes, I know cotangent over here is 1 over tangent. Try to get in terms of sine and cosine. So when you are simplifying trig expressions, we're just looking what we can replace it with. So cotangent is cosine over sine. So I'm going to, instead of cotangent, I'm just going to write cosine over sine instead, okay? Now, the bottom, let's deal with that part. So on the bottom, what we have is cosecant. So again, I'm going to go to my sheet and I'm going to say cosecant. How can I put that for now in terms of sine and cosine? So we're going to look at our sheet. Okay, cosecant, I'm going to find it, is 1 over sine. Okay, so I'm going to replace cosecant with big fraction bar, 1 over sine. I apologize for the squeaking. Okay, now from here, I'm just going to try to simplify this if I can. And I always say to you guys, what do we rather do? Well, we would much rather multiply by the reciprocal than divide by a fraction. So rather than dividing by 1 over sine, I am instead going to take the numerator, cosine theta over sine theta. I'm just going to rewrite the numerator. Rather than dividing by 1 over sine, I am multiplying instead by the reciprocal, which is sine over 1. Remember when we flip 1 over sine, it just becomes sine over 1. So now I'm just multiplying these two, right? So this step took me down here, cosine times sine over sine times 1. What happens when I have a sine on top and bottom? What do you guys think I can do? Well, you always tell me if I have the same thing on top and bottom, I can just cancel. So what am I left with? Just cosine of theta over 1, or cosine of theta. So this whole thing just simplified, okay? Cotangent theta over cosecant theta. I only used identities. I didn't just make these things up. They came from the sheet. Okay, so this is where I'm going to give you guys about 10 seconds. And then if you have any questions, this would be if you want to stop, write them down, email me, send me a remind message, type under this Google post, something. If you want some feedback, I'd be more than happy to help you. Okay? Okay, let's move on to our next example. Remember, our whole goal here with simplifying trig expressions is to use our identities and just get it to be simpler, okay? Get it to be much simpler. And the next one you'll find out will work out pretty nice. So our next example on your sheet is cosine of x times tangent of x. So now a common question I get here is, the other one had theta, this one has x. It doesn't matter. They're the same thing. If you like theta, you can put theta, okay? So I'm going to have cosine of x. Now, always put in terms of sine and cosine, and this is when all else fails. So I always recommend trying this if you're not sure what to do, especially in the beginning, okay, before you get good at this. So cosine times tangent. Cosine is already in terms of sine and cosine. Just leave it. Don't turn it into secant. Just leave it the way it is. So I'm just going to rewrite cosine, okay? But tangent, I can put that in terms of sine and cosine. Again, go to your identity sheet. We're going to look at it, okay? We're going to see. And where is it? Tangent, right up on top here. Tangent is, my finger find it, sine over, okay? So what am I going to do? Just what I did in the last one. I'm going to replace tangent with sine over cosine, okay? Anything that's not written is always over 1. Again, just like the last one, I have a cosine on top, cosine on the bottom, they cancel. So I'm just left with sine of x. Okay, so this is our next one, very similar. Put in terms of sine and cosine if we can, cancel it. How do we know we're done? We can't do anything there. And the first two examples are just some basic multiplication and division with these trig functions using your identity sheet. Always use a sheet, have it in front of you. And if you have any questions, like I said, feel free to contact me or play this video back if you need to look at it again. Okay? Okay. Now, our last example that we're going to look at is sine of x minus sine of x cosine squared x. So for a second, I want to stop here and I want to look, say for example, I gave you x minus xy squared and I said to factor out anything I could. So you would say, okay, what do these two have in common? I think you can both see that each one of these terms has an x. So I would just factor out an x and I'd be left with 1 minus, fold out the x, y squared, right? We are going to do the same thing here, just treat the trig functions as their own variables. So we're going to say, what do these two terms have in common? This one has a sign, that one has a sign. So I'm going to pull out a sign. What am I left with? Well, I pulled out the sign here. So I'm left with 1, my minus sign, I pulled out the sign. So I'm just left with cosine squared, okay? So now what makes this problem a little bit harder? Well, we kind of made it look a little bit uglier before it got better. And how do we know we're not done? Well, we have multiplication, we have subtraction. Let's see if there's anything we can do. Sine is already in terms of sine and cosine. We just leave it. Now I know this is already in terms of cosine, but whenever you see a 1 minus a cosine, a 1 minus a sine squared, 1 plus tangent, 1 minus cotangent, anything like that, when we have the squared term, check your identity sheet. If I look at my identity sheet, right? If I look at this identity sheet, we're going to take a look at the bottom of the identities. We want to know 1 minus cosine squared, what is that equal to? So I'm going to look on the sheet. 1 minus cosine squared, does everyone see how that is just here we go. 1 minus cosine squared is just sine squared. Okay, it's right here on that sheet. So what does that mean? So I'm just going to replace 1 minus cosine squared with sine squared. And then don't forget you have the sign on the outside to bring down. And then if I gave you, for example, so now how do we multiply these? They're trig functions. It's no different than variables. If I gave you x times x squared, okay, that's just x cubed. We have sine times sine squared, just sine cubed x, okay? So let me walk through this one again, our last example. So we're going to start this. We already have everything in terms of sine and cosine. We see a cosine squared, so maybe we're thinking one of those Pythagorean identities. That's how I want you guys to think when you start seeing trig functions squared. But I don't see anything yet. So the first thing I'm going to do is say, okay, I can pull out a sign. So I pull out a sign. I'm left with 1 minus cosine squared. I can't do anything with the sign. So now I'm going to say, what can I do with 1 minus cosine squared? I'm going to check my handy dandy identity sheet. Okay? And I see that 1 minus cosine squared is sine squared. I'm just replacing them using my sheet, and then I multiply them, and I end up with my answer. Okay, how do I know I'm done? I can't do anything with that. So that's how I know I'm done. Okay, before we finish up this video, those are all the examples I have for you. Just know that I have posted another Edpuzzle video on Google Classroom for you to take a peek at. If you just want to see, it's a different teacher doing different examples. They're not the same as these, but some are similar. Your homework that is going to be due the next time I see you is very similar to the problems I went over. I'm going to try to keep it similar. The first two examples I have on here are just like the first example I did on the notes. The next problem is just like the second example, and then the final problem is just like the third example I did on here. Okay, so let's see if you can try those, really try them yourself, and see how you do. If you need my help, you know there are many different ways to contact me. Okay? Good job today, and like I said, let me know if you need anything at all. This will be due by the next time I see you. You can take a picture and hand it in on the assignment tab under classwork in Google Classroom, or send me an email. Have a good day, guys.